In this concept video, we're going to be discussing angles of elevation and depression, and also give you some helpful hints here for solving more real-life or application-type problems. For angles of elevation and depression, one big thing that we want to understand with this is that they're really the same angle. So I'll put same right here. Hopefully you can see that there. It might be at the very top of your screen. These are always from the horizontal. We never read these from the vertical. So let's take a look at what this would look like in a triangle. Draw this triangle here, and this could be a variety of situations. It could be a situation where you've got an airplane and its altitude and it's approaching an airport. It could be someone looking at the top of a building, looking down. It could be someone here looking up at the top of a tree. There's lots of different ways that trigonometry is used in real life. When we talk about elevation and depression, it really just matters where you're looking from. So an angle of elevation, you'd be looking up. So this right here would be the angle of elevation. The angle of depression is a little bit more difficult. This one's the tricky one because we always take that from a horizontal. So we have to imagine a horizontal here that's perpendicular to the ground, and then that angle of depression is going to be right here. So here's your angle of depression, and then here's your angle of elevation. If you remember your geometry, you'll note that these are two parallel lines. We have a transversal. These are alternate interior angles. So if that helps you remember that the angles of elevation and depression are the same thing, they're like the same measure, we know that these two angles here are congruent, therefore their measures are the same. Just be very careful with that because some folks will try to draw a triangle and they'll automatically think this one here is the angle of depression. But just remember, we never measure from the vertical, we're always measuring from the horizontal, and really the angles of elevation and depression are the same darn thing. Let's talk about now some helpful hints on solving these real life problems. So I'll give you one nice hint here, and that is to draw a picture. This is a huge one. Draw a picture. Kind of like we did here before, we've been doing that a lot with reference triangles and some other things. Keep doing that. Draw a picture. It can really help you see the different parts of the right triangle that you might be able to form, or the triangle that you might be able to form. So the second thing I'm kind of leading into here is to try to set up a triangle. This unit is all about trigonometry, so with these types of problems we're going to be looking for a triangle. If we can set up a right triangle, that's great. If we can't, there's still things that we can do, so no worries there either. So the next thing is going to be, if it is a right triangle, not all will be, but some, then you can use Pythagorean theorem and your basic trig ratios. So we're talking about sine, cosine, and tangent, cosecant, secant, and cotangent if you need them. Normally you just need those three, the sine, cosine, and tangent. If it's not a right triangle, then of course we have to do some other things. So we're going to use the law of sines or cosines. The law of cosines or sines works for any triangle, so even it will work here on these. It just might be beneficial to try to use the Pythagorean theorem and your regular trig ratios. I mean, setting up the cosine as adjacent over a hypotenuse is a lot easier than trying to use the law of cosines. It would work for sure. You're just complicating yourself or your life just a little bit.